Hello guys, welcome to the first class of ITF. ITF is Inverse Trigonometric Function. So this is a very important concept. Direct problem are asked and it is used in other topics also. In continuity, differentiability, limits and integral calculus, areas, everywhere it is used. So we need to understand the basics of this chapter. Let us start now. Functions are invertible only if they are bijective. I hope you understand bijective 1, 1 on 2. We discuss all these things in detail in functions chapter. Now, trigonometric functions are not bijective in their domain, but we can restrict the domain to make them bijective. What, what do I mean by that? Example, sine x. F of x equal to sine x. You know the sine wave. Obviously, this function is not 1, 1, no, because multiple points will give you the same value. You can see 0, pi, 2 pi, everywhere value is 0. But if I restrict the domain here from minus pi by 2 to plus pi by 2, in that particular domain, you will see it will be 1, 1 also. And if I take codomain as minus 1 to 1, range will also be minus 1 to 1. So it will be on 2 also. So in this interval from minus pi by 2 to pi by 2, the function will be bijective. So if it is bijective, we can find the inverse also. Now, how do you find the inverse? If I take, if like f of x is sine x, how do you find inverse? You take sine of x equal to t, so x will be sine inverse t. So this is where we get it. From now, a function was from minus pi by 2 to pi by 2 to minus 1 to 1. So it's inverse function, domain and range will interchange. So the range of this will become domain here, domain of this will become range here. So f inverse function will be from minus 1 to 1 to minus pi by 2 to pi by 2, and f inverse x here will be sine inverse x. So this is called as principal domain here, which is domain only. This is called as principal range. Basically, you might argue that it could have been 1, 1 if I take from pi by 2 to 3 pi by 2. If I take from pi by 2 to 3 pi by 2, it will also be 1, 1 on 2. That could also serve as an interval. But there's a standard set here which is used throughout. That is this minus pi by 2 to plus pi by 2. This will be referred to as principal range. Just to set a standardized thing so that everyone will use that only. So this is principal range. So we have to use this only. Now, same way you can do it for other trigonometric functions. So I'll just give you the final thing for all of them. So sine inverse x, like we discussed, domain is minus 1 to 1, range is minus pi by 2 to plus pi by 2. For cos inverse x, domain is same, minus 1 to 1, and range here, the principal range here is 0 to pi, both closed. Tan inverse x, cot inverse x, both of them have domain, all real numbers. The range of tan inverse x is minus pi by 2 plus pi by 2, but both of them are open. Cot inverse x is 0 to pi, both of them are open. Next, secant inverse x, cosecant inverse x, domain of both of them is all real number except from minus 1 to 1. The principal range here for secant inverse is 0 to pi except pi by 2. For cosecant inverse x, minus pi by 2 to plus pi by 2 except 0. What you will notice here is, see, sine inverse, tan inverse, cot inverse, sine inverse, cos inverse, tan inverse, cot inverse, secant inverse, cosecant inverse have same domain. These pairs have same domain. For range, you will see that sine inverse x, tan inverse x, cosecant inverse x. Their range is almost similar with small changes. Sine inverse x is both closed, tan inverse x is both open, cosecant inverse x both closed but except 0. Same way cos inverse, cot inverse, secant inverse. Their range is almost same with small differences here also. And one more thing to notice here, cos inverse x, cot inverse x, and secant inverse x are never negative. You see, these values are never negative, only positive or zero is in the range. Okay, so this point will be useful later. Next, the graphs. Y equal to sine inverse x. How do you plot the graph? See, just domain is -1 to 1. You can just take some values to find points on the graph. Like what you can do if you want to find the value at -1. You see sine inverse of -1 is equal to y. So sine y will be equal to -1. And for what angle it will be -1? When y will be minus pi by 2. So value at -1 is minus pi by 2. Same way value at 0 will be 0. Value at 1 will be pi by 2. You just join them. This is how the graph of sine inverse x will look like. And you can see that it's an increasing function. Okay, this is also important. It will be used later. Next. Cos inverse x will come out to be a decreasing function with value at -1 to be pi. Value at 0 will be pi by 2. Value at 1 will be 0. Make sure you draw all those graphs in your notes so then only get better idea. Next. Tan inverse x will be increasing function. Value at minus infinity will be almost minus pi by 2. Value at 0 will be 0. Value at plus infinity will be almost pi by 2. You see both of them, like the brackets are open. So they will never meet these lines. Like the graph will never meet these lines. It will just keep on coming closer and closer to that. But they never meet. For cot inverse x will be decreasing function. Value at minus infinity will be pi. Value at 0 will be pi by 2. Value at plus infinity will be almost 0. Again, it will never meet the lines. Secant inverse x, you see the value at -1 will be pi, and before -1 value will be like going towards pi by 2. Value at 1 will be 0, and after 1 value will be going towards pi by 2. So this will be an increasing function. First it increases from pi by 2 to pi, then increases from 0 to pi by 2. Next, cosecant inverse x. For this, you see value at -1 will be minus pi by 2, value at 1 will be pi by 2. After 1, it will be coming closer to 0. Before 1, it will be coming closer to 0. So it will be a decreasing function. First 0 to minus pi by 2, then pi by 2 to 0. So you see, it will never meet 0. That is why 0 was open. Next. Now those identities we'll discuss some of the things which are always true for them. First, negative signs. How do we handle negatives here? Sine inverse of minus x will be minus sine inverse x. Tan inverse of minus x will be minus tan inverse x. Cosecant inverse of minus x is minus cosecant inverse x. You can see they are odd functions. Whereas cos inverse of minus x is pi minus cos inverse x. Cot inverse of minus x is pi minus cot inverse x. Secant inverse of minus x is pi minus secant inverse x. If you remember, for these three functions, the range was always positive. They were never negative. That is why we don't take negative sign outside. We have to write like this. And why this only, we'll discuss with the help of proof here. See, first we prove for sine inverse of minus x. Same we can prove others too also. Sine inverse minus x, let us say, is theta. So minus x will be sine theta, or we can say x is minus sine theta. And minus sine theta we can also write as sine of minus theta. So x will become sine of minus theta. So we can say sine inverse x will be minus theta. And theta was this thing. So get sine inverse x is minus of sine inverse minus x. So this proves first one. Same way you can prove second and third also. Let us see one of these now. Cos inverse minus x. Cos inverse minus x is, let us say, theta. So minus x will be cos theta. And x will be minus cos theta. And minus cos theta is same as cos pi minus theta also, no? Because cos 180 minus theta is minus cos theta. So you get cos inverse x will be pi minus theta. So theta will be pi minus cos inverse x. And what was theta? Theta was cos inverse of minus x. Hence proved. Same we can prove the other two also. But at the end of the day, just have to remember these. Next. And how do you find the negative values? Let us say you have to find tan inverse of minus 1. Again, take negative outside. Get minus tan inverse of 1. Tan inverse of 1 is pi by 4. So this will become minus pi by 4. If you have to find cos inverse of minus 1 by 2, you can write this as pi minus cos inverse of 1 by 2. Cos inverse of 1 by 2 is pi by 3. So pi minus pi by 3 will be 2 pi by 3. I hope it is clear, guys. Next. A complementary inverse. See, in the trigonometry, we discuss complementary trigonometric ratios. Same will play a role here also. If you have sine inverse x plus cos inverse x, it will be pi by 2. In their common domain, that is minus 1, 2. Tan inverse x plus cot inverse x, that will also be pi by 2 in the common domain, which is all real numbers. Sec inverse x plus cos sec inverse x will also be pi by 2 in the common domain, which is all real number except minus 1 to 1. How do you prove this thing? Easily we can prove here. Say sine inverse x is theta. So x will be sine theta. And cos 90 minus theta we can write for sine theta. So cos inverse x will be 90 minus theta. That means theta plus cos inverse x equal to pi by 2, where theta was sine inverse x. Hence proved. Okay, next. Reciprocals now. See, sine inverse x we can write as cos secant inverse 1 by x for x minus 1 to 1 except 0. Because you see at 0 this thing will not be defined. Cos secant inverse x we can write as sine inverse 1 by x for x all real number except minus 1 to 1. Basically the domain of cos secant inverse. Same way cos inverse x will be secant inverse 1 by x, secant inverse x will be cos inverse 1 by x in the same domains as the previous one. The important ones here are these. Tan inverse x will be cot inverse 1 by x when x is positive. But when x is negative, it will become cot inverse 1 by x minus y. Why we have to minus pi here? Because for negative values, tan inverse x will come out to be negative number. But if you remember, cot inverse is always positive. So to make it negative, we have to subtract pi. And we can add or subtract pi because period of tan is pi. So if you add or subtract pi, you get same thing. Nothing changes there. So only to make it negative, we have to subtract pi here. Same way, cot inverse x is tan inverse 1 by x when x is positive. But when it is negative, then we have to do tan inverse 1 by x plus pi. Because now cot inverse will be positive only, but tan inverse will be negative. So to make it positive, we have to add pi. I hope it makes sense, guys. This is a very, very important point. Many questions are based upon this thing. So do understand this thing properly. How do you prove this thing easily? You can prove, so let us say sine inverse x is theta. So x will be sine theta, and then 1 by x will be cosecant theta. So cosecant inverse 1 by x will become theta. And theta was sine inverse x. Hence proved. Okay, next. Now there are some practice problems, guys. I'll just show you. You can pause and try them. First, find the value of following: sine inverse square root 3 by 2, cos inverse 0, sine inverse minus 1 by 2, tan inverse minus 1, tan inverse square root 3, cot inverse 1 by square root 3, cos inverse minus 1 by 2, secant inverse minus 2 by square root 3. You can pause and do it. Next problem is find the maximum and minimum value of step of sine inverse x plus step of cos inverse y. Okay, this is a step function. You can pause and give it a try. Next. Find the domain of following function. First is sine inverse x plus cos inverse x plus tan inverse x. Second is cos inverse x plus cos secant inverse x. Third is cos inverse 1 minus x square plus sine inverse 1 minus x. Fourth is square root of 3 cos inverse 4x minus pi. Fifth is square root of cos inverse x minus sine inverse x. Sixth is sine inverse 1 plus x square by 2x. Seventh is square root of cos inverse x minus cos inverse of x square. Eighth is square root of 7 cot inverse x minus cot inverse x whole square minus 12. Next, fourth problem. Find the range of following functions. So we have 6 of them. First is sine inverse x plus cos inverse x plus tan inverse x. Second, sine inverse x plus secant inverse x. Third, tan inverse x plus tan inverse 1 by x. Fourth, tan inverse 2x by 1 plus x square. Fifth, cot inverse 2x minus x square. Sixth, cos inverse square root of 1 plus 2x square by 1 plus x square. Okay, now let us discuss their key and solution. So first I think directly you can check here is pi by 3, pi by 2, minus pi by 6, minus pi by 4, pi by 3, pi by 3, 2 pi by 3, 5 pi by 6. Second is just maximum value is 4, minimum value is minus 2. Maximum will be 4 when first is 3, second it's like 1 plus 3 is 4. And for minimum, first will be minus 2, second will be 0, you get minus 2. I hope these first two problems are clear to everyone. Next, third one. First one is answer is minus 1 to 1. Second, the answer is just minus 1 and 1. The common points in their domain will be only minus 1 and 1. From third one, we'll discuss in detail here. So cos inverse 1 minus x square plus sine inverse 1 minus x. So to make sure the thing inside cos inverse is minus 1 to 1, thing inside sine inverse is minus 1 to 1. When you solve this thing, get x belongs to minus square root 2 to plus square root 2. When you solve this thing, get x belongs to 0 to 2. Common values are close 0 to square root 2. This is your final answer. Next one. Fourth one, the final answer is minus 1 by 4 to 1 by 8. If you did not get this thing, see now. So first of all, the thing inside cos should lie between minus 1 to 1. So 4x lie between minus 1 to 1, x lie between minus 1 by 4 to 1 by 4. Next, the thing inside square root should be greater than or equal to 0. So you get cos inverse 4x greater than or equal to pi by 3. Now, you know cos inverse x we discussed was a decreasing function. So if I take cos that side, then equality will change. Right now it is cos inverse 4x greater than or equal to that. If I take cos that side, inequality will change. You get 4x is less than or equal to cos pi by 3. So x should be less than or equal to 1 by 8. Because cos pi by 3 will be 1 by 2. So if it is common values, common will be minus 1 by 4 to 1 by 8. I hope it is clear to all of you guys. Next. Next we have square root of cos inverse x minus sine inverse x. Just the thing inside square root should be greater than or equal to 0, and x obviously should lie between minus 1 to 1. So cos inverse x you can write as pi by 2 minus sine inverse x, so will become pi by 2 minus 2 sine inverse x greater than or equal to 0. So sine inverse x will be less than or equal to pi by 4. And if you take sine that side, you know sine is increasing function, so inequality will be same. So we get x less than or equal to sine pi by 4, which is 1 by square root 2. So maximum value of x is 1 by square root 2, minimum can be minus 1, so x lie between minus 1 to 1 by square root 2. This is one way. Second, you can do with the help of graph also, just plot both the graphs. This is sine cos inverse x graph. This is sine inverse x graph. What do you want? You want cos inverse x to be more than sine inverse x. You see from minus 1 to 1 by root 2. Cos inverse x will be greater than or equal to sine inverse x. So x belongs to minus 1 to 1 by square root 2. Next. Sine inverse 1 plus x square by 2x. Here you see the range of this thing. This we can write as 1 by 2x plus 1 by x. Using A and GM, we can say range of this thing will be minus infinity to minus 1 union 1 to infinity. And inside sine inverse you can only put plus or minus 1. So this thing should be either plus 1 or minus 1 because nothing else in the range of this thing matches here. So 1 plus x square by 2x equal to plus or minus 1. When you solve, you get x equal to plus or minus 1. So domain will be only minus 1 and 1. Only two numbers are there. Next one. The thing inside square root again has to be greater than or equal to 0. So cos inverse x minus cos inverse x square greater than or equal to 0. So cos inverse x should be greater than or equal to cos inverse x square. And again, if I cancel out cos inverse, inequality will change because cos inverse x is decreasing function. So get x square minus x greater than or equal to 0. Use wavy curve here. Roots are 0 and 1. Positive, negative, positive. You want greater than or equal to 0. And x obviously will lie between minus 1 to 1 also. So less than 0, that means minus 1 to 0 or only 1. More than 1 we cannot take, but we can take equal to 0 also, no? So at x equal to 1, it will be 0, so it will be true. So final answer is close minus 1 to close 0 union 1. I hope it is clear, guys. Next. Okay, eighth answer is minus infinity to cot 3 closed. See how we get this thing. So 7 cot inverse x minus cot inverse x whole square minus 12 greater than or equal to 0. So cot inverse x whole square minus 7 cot inverse x plus 12 is less than or equal to 0. If you use that wavy curve on this thing, get cot inverse x minus 3, cot inverse x minus 4 less than or equal to 0. So root of cot inverse x comes out to be 3 and 4, positive, negative, positive. So from here, cot inverse x should lie between 3 and 4. But range of cot inverse x is 0 to pi, and pi is like 3.14, no? That means it can be more than 3, but up to pi only. So we get cot inverse x should be greater than or equal to 3, less than pi. If I take cot to other sides, again, cot is a decreasing function, so inequality will change. So get cot 3, this will become minus infinity because cot pi will be minus infinity. So x comes out to be between minus infinity to cot 3, minus infinity open, cot 3 closed. This is a good problem, guys. Make sure you understand this thing. Next. The range problem. See, the first answer is pi by 4 to 3 pi by 4. Easily we can say the domain of this thing, first of all, is minus 1 to 1. And in that interval, this will be just pi by 2. So become pi by 2 plus tan inverse x. Tan inverse x at minus 1 will be minimum, which will be minus pi by 4. Add to pi by 2, you get plus pi by 4. At 1, it will be maximum, which will be pi by 4. When you add here, you get 3 pi by 4. Next, sine inverse x plus sec inverse x. Here, domain is minus 1 and 1. Only two numbers. And when you put minus 1, you get pi by 2. When you put 1, you get pi by 2. So in the range, we have only one number, that is plus pi by 2. Next, tan inverse x plus tan inverse 1 by x. This we have discussed already, is the important thing. If x is greater than 0, tan inverse 1 by x will be cot inverse x. Then tan inverse x plus cot inverse x will be pi by 2. But if x is less than 0, then tan inverse 1 by x will be cot inverse x minus pi. So tan inverse plus cot inverse will be plus pi by 2 minus pi, you get minus pi by 2. So range here is only two numbers, minus pi by 2 or plus pi by 2. Next, tan inverse of 2x by 1 plus x square. In this kind of problem, you just find the range of the thing inside. You see 2x by 1 plus x square. Again, using a and gm, we can easily prove this range will be minus 1 to 1. Then put minus 1 here and 1 here. When you put minus 1, you get minus pi by 4. When you put 1, you get plus pi by 4. That's all. Answer will be minus pi by 4 to plus pi by 4. Basically, just find the range of the thing inside and then put the boundary values. They'll give the boundaries of the range also. Required range. Okay, same thing here. Fifth one. Cot inverse 2x minus x square. Find the range of this thing will be minus infinity to plus 1 closed. So at minus infinity, you get pi by, sorry, cot inverse minus infinity is pi, cot inverse 1 will be pi by 4, so close pi by 4 to open pi. Last, cos inverse square root of 1 plus 2x square by 1 plus x square. First of all, cos inverse of this thing we can write as sine inverse of x square by 1 plus x square. Which formula I'm using? I'm using cos inverse x, we can write as sine inverse root of 1 minus x square. Where do we get this from? We'll discuss the next concept. Okay, so I'll discuss next concept where we will discuss this thing in detail. Right now I'm just using it directly. We get sine inverse of x square by 1 plus x square. The range of this thing again you can find easily. Many methods you have, close 0 to open 1. So now put boundary values here. When you put 0, you get 0. When you put 1, you get pi by 2. So it will also be close 0 to open pi by 2. I hope guys these domain range problems are clear. They are just basic problem but will be used in some more typical problems. So understanding them is important. Next, another thing I discussed, converting sine inverse to cos inverse. See, sine inverse x we can write as cos inverse of square root 1 minus x square when x lie from 0 to 1. Basically for positive values of x. And it will be minus cos inverse root 1 minus x square when x is negative. Basically minus 1 to 0. In case of cos inverse x, it will be sine inverse root 1 minus x square when x is positive, basically 0 to 1. And it will be pi minus sine inverse of root 1 minus x square when x is negative, basically minus 1 to 0. Again, same thing coming into play. Cos inverse x is never negative. So we are not just putting negative outside, we have to take pi minus sine inverse. Okay, so proof also. I'll discuss few proofs, others you will be able to do on your own. I'm just doing the first one. So when x is positive, assume sine inverse x to be theta. So for x positive, sine inverse x value will lie between 0 to pi by 2. So x will be sine theta, and if sine theta is x, cos theta will be plus minus root of 1 minus x square. Remember this identity, sine square theta plus cos square theta is 1. If you put sine theta x here, you get cos theta to be plus minus root of 1 minus x square. But theta lies in first quadrant, so we have to take positive sign only. So cos theta will be plus. So theta will come out to be cos inverse of square root 1 minus x square. This is the proof of the first one. Second one, negative numbers, same thing almost. When x is less than 0, assume x to be minus y, so y will be positive now. So sine inverse x we can write as sine inverse of minus y, which we can write as minus sine inverse y. And sine inverse y, when y is positive, we can write as cos inverse of root 1 minus y square. We have proved in the first part. So we get minus cos inverse root 1 minus y square, and x is minus y, so y square will be x square only. So we get minus of cos inverse root 1 minus x square. Same way can prove this cos inverse x also. But at the end of the day, just need to know the results. Directly we can use. Next one, guys. Now some important functions. See, first is sine of sine inverse x. Sine of sine inverse x will just be x. In functions, we do know f of f inverse x is x. Same thing, it will be just x. And domain we take of internal function, that is minus 1 to 1. And the codomain or range we take for the external function, which will be minus 1 to 1. So see, it's an identity function, like y equal to x. But in the interval minus 1 to 1 only. This is how the graph will look like. Y equal to x line from minus 1 to 1. Same way we can do for all the remaining. Cos of cos inverse x, tan of tan inverse x, cot of cot inverse x. All of them will be identity function equal to x in their respective domains. Domain will be minus 1 to 1 for cos. For tan and cot will be all real number. For secant, cosecant will be all real number except minus 1 to 1. And range will also be same because identity function y equal to x. Whatever x you put, same you get y. Okay, these are direct, these are easy. The important one will be other way around when we do sine inverse of sine x. Now this is very, very, very important. The problems will be mostly based upon this thing only. So make sure you understand this thing properly, guys. I'll discuss this in detail. We have f of x equal to sine inverse of sine x. The problem here is the domain we take for sine x, which is all real numbers, and range we take of sine inverse, which will be minus pi by 2 plus pi by 2. In the previous problem, domain and range were same. There was no problem. But here, range and domain are not same. Because if you remember, sine x domain we restricted to find sine inverse. But when for sine inverse sine x, you don't need to restrict x value here. No, x you can put anything. This value will come between minus 1 to 1 only. Okay, so this we have to discuss how to solve this thing. Two more things here. The period of this function. See, period of this function will be 2 pi, same as sine x, because this sine x value will repeat after 2 pi. So it will make whole thing repeat after 2 pi. And one more thing will be an odd function. If I put x as minus x, the minus will come outside. It will be an odd function. Okay, these points will be helpful later. Now, what you have to remember here, you have to remember these three always. Sine inverse sine x will be x when x belongs to minus pi by 2 to pi by 2, both closed. It will be pi minus x when x belongs to pi by 2 to 3 pi by 2. You see, I have closed pi by 2 here also, here also. It won't make any difference because both the time you get value pi by 2 only. Either you put here or here. So pi minus x from pi by 2 to 3 pi by 2 and minus pi minus x when x belongs to minus 3 pi by 2 to minus pi by 2. How do we say this thing? We'll prove here, but at the end of the day, you have to remember these guys. They are very, very important. See, first of all, sine inverse sine x is x when x lies in the range. Keep this in mind. Whenever x lie in the range, we just cancel them out. Not exactly cancelling, but keep in mind that we are cancelling out. It will just be x. Only when x lies in the range of the function. What do we do otherwise? We try to bring x in the range. See how? In this case, x belongs to pi by 2 to 3 pi by 2. Not in the range, but pi minus x when you see, if I put x as pi by 2 here, you get pi by 2. If I put x as 3 pi by 2 here, you get minus pi by 2. So pi minus x lies in the range. How will that help us? You know, sine inverse of sine x. You know, sine x is equal to sine of pi minus x. Sine x is equal to sine pi minus x. Now we have sine inverse of sine pi minus x. Now pi minus x lies in the range, so we can cancel sine and sine inverse. We get pi minus x. That's all. I hope it makes sense. Same thing in the last one also. Here x belongs to minus 3 pi by 2 to minus pi by 2. In this case, minus pi minus x will lie in the range from minus pi by 2 to plus pi by 2. You can check that. Now sine inverse of sine x we can write as sine inverse of sine pi minus x. And period of sine x is 2 pi, so I can add or subtract 2 pi, no problem. So when I subtract 2 pi from here, you get minus pi minus x. And minus pi minus x lie in the range, so we can cancel sine inverse and sine. A small misprint here. It's supposed to be sine inverse of sine. So we can cancel sine inverse and sine here. We get minus pi minus x. This is how we get this thing. But at the end of the day, like I told you, you have to remember this thing. Next is graph of this thing. Remember, the graph of this thing is a zigzag graph. See, between minus pi by 2 and pi by 2 will be straight line y equal to x. Between pi by 2 and 3 pi by 2 will be straight line y equal to pi minus x. And before that, minus 3 pi by 2 minus pi by 2 will be a straight line minus pi minus x. And like we discussed, the period is 2 pi. So whatever graph you see from 0 to 2 pi, same thing will repeat everywhere. So 0 to 2 pi is like this, no? Same thing will repeat everywhere. So a zigzag graph. Just keep this thing in your mind, zigzag graph. That's all. Next, how do we solve sine inverse of sine x? This is very important, guys. These kind of problem usually they ask. If x is negative, we take negative outside because the odd function, no? So sine inverse of sine of say -5 or -4. You can write as minus sine inverse of sine 4. Odd function negative we can take outside. Now write x in intervals of pi by 2. Like for example, if I have say x as say pi, we can write pi as less than 3 pi by 2, more than pi by 2. Okay, you will see with the help of examples also. What do I mean by this? Then keep on subtracting 2 pi until it comes in any one of these intervals. Why 2 pi? Because period of sine x is 2 pi. So if I add or subtract 2 pi, it doesn't make any difference. And we keep on doing that till the things comes in a range. Either it will come into minus pi by 2 to pi by 2, directly we can say x. And if it comes between pi by 2 and 3 pi by 2, then we can write pi minus x. We discussed already. See with the help of example, what do I mean by this? Let us say we have sine inverse of sine 10. See, 10 is a radian here, it's not degrees. And 3 pi will be approximately 9.42. Pi is around 3.14, no? So guys, 10 will be less than 3 pi plus pi by 2 and more than 3 pi minus pi by 2. This is in intervals of pi by 2's. I could have written 10 as 3 pi to, I could have written 10 as 3 pi to 4 pi also. But write in terms of pi by 2's for sine. It will help you compare finally. If I subtract 2 pi, you get 10 minus 2 pi will lie between, like if I subtract 2 pi from here, it will become plus pi by 2. If I subtract 2 pi from here, you get 3 pi by 2. So 10 minus 2 pi will lie between pi by 2 and 3 pi by 2. When we discuss if it lie between pi by 2 and 3 pi by 2, answer will be pi minus x. So this thing will serve as x here, so it will be pi minus x, you get 3 pi minus 10. That is your final answer. Okay, this is very, very important, guys. Make sure you understand this thing. Then try this next one yourself. One second. Sine inverse of sine of minus 12. Pause the video, give it a try. Let's start this question. The final answer here is 4 pi minus 12. If we haven't got this thing, let us see. Sine inverse of sine of minus 12, negative outside, you get minus of sine inverse of sine 12. Now 12 we can write as 4 pi minus pi by 2 to 4 pi plus pi by 2. See, the length of the interval should be pi only. It should not be more than that. Otherwise, it will be of no use. Make the length of interval to be pi only. Now you can directly subtract 2 pi, like 2 times you get 12 minus 4 pi. Because if you subtract 2 pi 2 times, you get this thing directly between minus pi by 2 and plus pi by 2. And between minus pi by 2 and plus pi by 2, directly will be x only. So this thing will just become 12 minus 4 pi, negative outside, you get 4 pi minus 12. This is your final answer, guys. Okay, next. Next we have cos inverse of cos x. Let us discuss this thing in detail now. Same we will discuss like we have done for sine inverse of sine. See, the domain here also will be all real numbers, just like cos x, just like sine x. Domain of cos x is all real numbers. The range we take of cos inverse, which will be 0 to pi. Okay, always in this composite function, we take domain of internal and range of external. So domain is all real number, range is close 0 to close pi. Again, period will be 2 pi, and it will be an even function because if you remember, cos of minus x will be equal to cos of x. So it will be an even function. Now, cos inverse of cos x, just like we discussed for sine inverse of sine x, for cos inverse of cos x, you have to remember these 3 points. In 0 to pi, it will be x because that is the range. If it is pi to 2 pi, it will be 2 pi minus x. If it is minus pi to 0, it will be minus x. How do we get this thing? I'll just quickly prove one of them. Remaining is same as sine over sine x. If x lie from pi to 2 pi, you will see that 2 pi minus x will lie between 0 to pi. And cos inverse of cos x, cos x is equal to cos 2 pi minus x. So cos inverse of cos 2 pi minus x, 2 pi minus x lies in the range, so we can cancel out to get 2 pi minus x. That's all. Same way you can prove third one also, and no need to do it. Directly can remember and use it. Graph of this thing will also be a zigzag graph, but with small changes. Now between 0 and pi, it will be y equal to x. Between minus pi and 0, it will be minus y equal to minus x. Between pi and 2 pi, it will be 2 pi minus x. This point here will be 2 pi. Okay, and like we discussed, period will be 2 pi. So whatever graph you see between 0 and 2 pi, same thing will repeat everywhere. Okay, this is minus 2 pi. Next, how to solve cos inverse of cos x? First point, if x is negative, drop the negative sign because it is an even function. It will just absorb the negative. Value will be same as positive one. Write x in intervals of pi. Now we write intervals of pi because we have to compare with 0 to pi or like pi to 2 pi. Again, keep on subtracting 2 pi until it comes in any one of these intervals. If it comes between 0 and pi, we say it is x. If it comes between pi and 2 pi, we say it is 2 pi minus x. Okay, let us see with the help of examples. See, we have cos inverse of cos of minus 8. So cos minus 8 will be same as cos 8. So just drop the negative sign. Now 8 will lie between 2 pi and 3 pi. Subtract 2 pi here, you get 8 minus 2 pi lie between 0 and pi. And if it lie between 0 and pi, directly we can say cos inverse of cos x will be x only. So answer will be 8 minus 2 pi. I hope it makes sense to all of you guys. Next. Next we have tan inverse of tan x. Here the domain of tan x, which is all real number except odd multiple of pi by 2. Range of tan inverse x, which is minus pi by 2 plus pi by 2, both open. Period for this function is pi, and it is again a odd function. This is very easy. You don't have to remember too much here, and these also you don't have to remember like too much here. Just if x lies in the range, it is directly we can cancel out tan inverse and tan, it will be just x. If x is more than that, we subtract pi. If x is less than that, we add pi. That is all you have to remember. So if x is from pi by 2 to 3 pi by 2, we subtract pi. It will come in the range. And if x is from minus 3 pi by 2 minus pi by 2, we add pi. It will come in the range. That's all. The graph here simply be like parallel lines. So y equal to x from minus pi by 2 to plus pi by 2. Y equal to x minus pi from pi by 2 to 3 pi by 2. Y equal to x plus pi when x lie between minus 3 pi by 2 minus pi by 2. And same lines will be there everywhere because the period is pi. So whatever graph you see between minus pi by 2 and pi by 2, same thing keeps on repeating. How to solve tan inverse of tan x? Again, if x is negative, take a negative outside because the odd function. Write x in intervals of pi by 2's. Then keep on subtracting pi because period now is pi until it comes in the range minus pi by 2 to pi by 2. There is no other interval you have to check. Just it should keep on subtracting pi until it comes in the range. Then just cancel out tan inverse and tan. For example, we have tan inverse of tan 9. You see 9 will lie between 3 pi minus pi by 2 to 3 pi plus pi by 2. So directly subtract 3 pi. So it will become minus pi by 2 to plus pi by 2. It comes in the range. So answer will be 9 minus 3 pi. I hope it is clear to all of you guys. Next. Converting inverse function. What do I mean by that? See, we discussed how to solve cos of cos inverse x, which was x only. But what if it is cos of tan inverse of something? The first example, cos of tan inverse 3 by 4. How do you solve this thing? Let us say tan inverse 3 by 4 is theta, and then tan theta will be 3 by 4. Make a small right angle triangle in which angle is theta. So if tan theta is 3 over 4, you can say perpendicular is 3, base is 4, so hypotenuse will be 5. So this thing we assumed it to be theta, so it will just become cos theta, no? So cos theta I can find from this triangle will be 4 over 5. That's all. This is the final answer. It's pretty easy. Okay, give it a try for next problem. Next problem is tan of cosecant inverse root 41 by 4. Let's start discussion. The answer for this is 4 over 5. I hope you can easily solve this thing. Next one. Cos of tan inverse of minus 2 by square root 3. Give it a try. The answer for this will be square root 3 by square root 7. If you haven't got this thing, see. We have cos of tan inverse minus 2 by square root 3. First, you can take negative outside. Always handle the negative first. Don't use the triangle thing on negative number because we're using it for acute triangle only. So negative you have to handle. So take negative outside here, you get cos of minus tan inverse of 2 over square root 3. And you know cos of minus theta is cos theta only. So inside cos, negative will be vanished. So get cos tan inverse 2 by square root 3. Then you can just do the same thing. This you take as theta. Tan theta is 2 over square root 3. Using triangle, cos theta will be square root 3 by square root 7. This is easy only then. Okay, the last one. This is a bit typical. Tan 1 by 2 cos inverse root 5 by 3. Give it a try, guys. This is a good problem. Let's start discussion now. The answer here is 3 minus square root 5 by 2. See, what do we do here? We say cos inverse root 5 by 3 as theta. So you see, cos inverse for positive number. The value of the theta will lie between 0 to pi by 2. This is important here. So cos theta will be root 5 by 3 and theta is acute angle. You can use triangle. You get sin theta to be 2 over 3. And then tan theta by 2. With the best formula to find tan theta by 2, it is 1 minus cos theta by sin theta. So put value of cos theta, put value of sin theta. You solve, you get 3 minus square root 5 by 2. Okay guys, next we have conversions. Now these are important, specifically this one. This you will see in limits, continuity, differentiability, even in integrals also. Same thing they'll ask there. So we have first one sine inverse 2x by 1 plus x square. This we can write as 2 tan inverse x when x belongs to closed minus 1 to closed 1. It will be pi minus 2 tan inverse x when x is greater than 1 and minus pi minus 2 tan inverse x when x is less than minus 1. Okay, we'll discuss the proof also, how we can prove this thing. But at the end of the day, you need to remember the result because this result directly will help you. So see the proof here. First of all, we put x as tan theta. So theta will be tan inverse x. And you know, range of tan inverse x is minus pi by 2 to pi by 2, both open. So theta belongs to minus pi by 2 to pi by 2, both open. So this thing will become sine inverse of 2x by 1 plus x square will become sine inverse 2 tan theta by 1 plus tan square theta. And if you know, this is the formula of sine 2 theta. This is what we discuss in trigonometry. So get sine inverse of sine 2 theta, and theta was from minus pi by 2 to pi by 2. So 2 theta will lie between minus pi to pi, both open. But in minus pi to pi, directly we cannot say anything about sine inverse of sine 2 theta. So we need to make intervals here, cases here. First case would be when 2 theta belongs to close minus pi by 2 to close pi by 2. In that case, theta will be minus pi by 4 to pi by 4. And x, which was tan theta. So when theta is minus pi by 4 to pi by 4, x will belong to minus 1 to 1. In this case, we get sine inverse of sine 2 theta as 2 theta only. Like we discussed, if x lies in the range, we can cancel out sine and sine inverse. So just get 2 theta because 2 theta lies in the range of sine inverse. And theta, as we discussed, was tan inverse x. So 2 theta will be 2 tan inverse x. This is how we get the first case. That it will be 2 tan inverse x when x belongs to -1 to 1. I hope it is clear, guys. Next interval I'll make when 2 theta belongs to minus pi to minus pi by 2, then theta will be minus pi by 2 to minus pi by 4. X, which is tan theta, will belong to minus infinity to minus 1. And sine inverse of sine 2 theta. If you remember, in minus 3 pi by 2 to minus pi by 2, sine inverse of sine x was minus pi minus x. So we get minus pi minus 2 theta, which will become minus pi minus 2 tan inverse x. So when x is less than minus 1, we get minus pi minus 2 tan inverse x. And the third one, when 2 theta belongs to pi by 2 to pi, theta will belong to pi by 4 to pi by 2, x will belong to 1 to infinity, and sine inverse of sine 2 theta will become pi minus 2 theta. Here we use the interval pi by 2 to 3 pi by 2. So when x belongs to pi by 2 to 3 pi by 2, sine inverse of sine x was pi minus x. So we get pi minus 2 tan inverse of x. So this is the proof here, just for your understanding. At the end of the day, if you remember the result also directly, it will work. Next one, guys. So next one, you can give it a try yourself. We have cos inverse of 1 minus x square by 1 plus x square. Same way, if you put x as tan theta, upon simplification, we get this thing to be 2 tan inverse x for x greater than or equal to 0 minus 2 tan inverse x for x less than 0. Same, we can prove this thing also. Put x as tan theta, theta will be tan inverse x, will lie between minus pi by 2 to pi by 2. This will become cos inverse of 1 minus tan square theta by 1 plus tan square theta, which will be cos inverse of cos 2 theta. And 2 theta will now lie from minus pi to pi. So now we just need to make two intervals, 2 theta from 0 to pi, because if we remember, cos inverse range is 0 to pi. So in 0 to pi, cos inverse of cos 2 theta will be 2 theta, and you get 2 tan inverse x. And theta here will be 0 to pi by 2. X, which is tan theta, will become 0 to infinity. Second case, when 2 theta belongs to minus pi by 2 to 0, so theta will be minus pi by, so 2 theta will be minus pi to 0, so theta will be minus pi by 2 to 0, so x belongs to minus infinity to 0, and in this case, cos inverse of cos 2 theta will be minus 2 theta. For minus pi to 0, cos inverse of cos x was minus x. So we get minus 2 theta, which will be minus 2 tan inverse x. So we get this result. This rarely they ask, but you can remember this, otherwise you can prove it any day. Okay, next. So two more I'll give you, you can try to prove them on your own. Tan inverse of 2x by 1 minus x square will be 2 tan inverse x when x belongs to minus 1 to 1, both open. You can see plus minus 1 will not be in the domain here, because denominator will become 0. For x more than 1, it will be 2 tan inverse x minus pi. For x less than minus 1, it will be 2 tan inverse x plus pi. You can easily prove this thing by taking x as tan theta. Next, sine inverse of 3x minus 4x cube. This will be 3 sine inverse x for x belonging to minus half to half. Pi minus 3 sine inverse x when x belongs to half to 1. And minus pi minus 3 sine inverse x when x belongs to minus 1 to minus half. This you can easily prove by taking x as sine theta. Then you have to use the formula of sine 3 theta. Okay, next, guys. Next are sum and differences formulae. So first one we have here, tan inverse x plus tan inverse y. See, there are cases involved here. I'll give you the clarity of how do we get this thing, and how do we get the cases, so that you don't need no need to mug it up. You understand the concept here, you will remember it automatically. First of all, tan inverse x plus tan inverse y will be tan inverse of x plus y by 1 minus xy. See, how do we get this thing? With the help of this proof. See, tan inverse x is A and tan inverse y is B. So basically from here x will become tan A and y will become tan B, which we might use later. So tan of A plus B will be tan A plus tan B by 1 minus tan A tan B. If I take tan this side, you get A plus B equal to tan inverse. And like we discussed, x will be tan A. So x plus y by 1 minus xy. So A will be tan inverse x, B will be tan inverse y. So tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. This is under normal condition. When do things go abnormal? See, the denominator. The denominator can mess up the things. See, if xy is less than 1, the denominator is positive, things are under control. Okay, we can directly say tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. But the things will go out of control when the denominator is negative, and it will be negative when x into y is more than 1. So when x into y is more than 1, then what will happen? You see, product is positive, so two possibilities are there. Either x and y are positive or x and y will be negative. Let us discuss first case when x and y are positive. So if x and y are positive, we can say this value will come out to be positive, this value will come out to be positive, so some of them will be positive. So left side is positive. But on the right side, you see x plus y will be positive, but the denominator will become negative. So finally, this value will come out to be negative. So left side is positive, right side is negative. So to balance the thing, we have to add pi. Like we discussed, tan x period was pi, so we can add and subtract pi to balance out the things anytime. So this is positive, this is negative, we add pi. When do we add pi? When the denominator becomes negative. It becomes negative when xy is more than 1. And x and y both are positive. Second case, when x and y are negative. When x and y are negative, you will see the left side will be negative. But this will come out to be positive, which will make this thing to be positive. So left side is negative, right side is positive. To balance out the thing, we subtract pi. So this side will also come out to be negative then. Okay, so understand this logic, guys. Then you don't have to mug up the conditions. You can use it, like you can recall them anytime when required. So if denominator is positive, no issue. But if denominator is negative, then depending upon x and y sign, we have to add or subtract pi. Okay, next one. Same logic here. So if you have tan inverse x minus tan inverse y, it will be tan inverse x minus y by 1 plus xy when denominator is positive. And denominator will be positive if x into y is more than minus 1. But if x into y is less than minus 1, denominator will be negative, then we have to see numerator. So if x into y less than minus 1, that means product of two numbers is negative. So there are two possibilities, either x positive, y negative, and another possibility also there. First, we'll discuss about this possibility when x is positive, y is negative. You see, when x positive, this will be positive. This thing will be negative, but negative will make it positive also. So the left side will be positive, but this part when you see will come out to be negative. So left side positive, right side negative, we add pi. And similarly in the next case, you will see that left side will be negative, right side will be positive. So we'll subtract pi. I hope it makes sense, guys. These conditions you have to remember because questions will be asked based upon this. Let us see some examples now. So first example I will discuss with you, then you can try. Tan inverse 2 plus tan inverse 3. You see, use the formula tan inverse 2 plus 3 by 1 minus 2 into 3. You see that xy thing is more than 1, no? Like the denominator is negative here. But these two, x and y, both are positive, so we have to add pi. So get tan inverse of 2 plus 3 by 1 minus 2 into 3 plus pi. This will become tan inverse of minus 1 plus pi. This will be minus pi by 4 plus pi, you get 3 pi by 4. I hope it is clear, guys. Next. Cos inverse 4 over 5 plus sin inverse 5 over 13. Remember, the formula for sine and cos are very typical. The conditions are too messy there, and to remember them will be too difficult. What you do is, every problem you try to solve in tan inverse. So if the question is given in cos and sine, using the triangle thing we discussed earlier, no? We take this thing as theta, then cos theta, tan theta. So using the triangle thing, convert into tan inverse. So this will become tan inverse 3 by 4, this will become tan inverse 5 by 12. And then you can use the formula. You get tan inverse of 3 by 4 plus 5 by 12 divided by 1 minus 3 by 4 into 5 by 12. In this case, denominator will be positive. So directly we can use the regular formula. You get tan inverse of 56 by 33. This is your final answer. Okay, now we'll discuss a typical problem. I'll give you time to try. We have a number of integral ordered pairs x comma y satisfying the equation tan inverse 1 by x plus tan inverse 1 by y is equal to tan inverse 1 by 10. You can pause it and give it a try. Let us start discussion now. First of all, we can just use the formula tan inverse 1 by x plus tan inverse 1 by y divided by 1 minus 1 by xy. You will see that denominator here will always be positive because x and y are integers. So you will see that 1 by xy can never be more than 1. 1 by xy will always be less than 1 only because x and y are integers. So directly use a regular formula, you get this thing is equal to tan inverse 1 by 10, only possible if this thing is equal to 1 by 10. So when you simplify, you get like this, y plus x by xy minus 1 equal to 1 by 10. Now, what you do is eliminate x or y in terms of other. So I'm eliminating y in terms of x. You got y equal to 1 plus 10x over x minus 10. See, this technique is very, very important in all these kind of problems when they ask integral ordered pairs and you get some equation in x and y like this. This technique will always work. So write y in terms of x here, 1 plus 10x over x minus 10. Now try to get rid of x from the numerator. Try to get rid of x from the numerator. So we have 1 plus 10x and denominator is x minus 10. So what I'll do is I'll take x as a bracket and take x minus 10 plus 10. So with x you add and subtract 10 so that we can split here now. So this will become 1 plus 10 times x minus 10 plus 100. So when you split that, you get this thing. This 10 times x minus 10 by x minus 10 will become 10. And 1 plus 100 will become 101 by x minus 10. Now, if you want y to be integral, x minus 10 has to be a divisor of 101. That's all. X minus 10 has to be divisor of 101. So you will see 101 is a prime number. So only possibilities will be plus minus 1 or plus minus 101. Now you can solve it. If you take x minus 10 as say plus 1, x minus 10 as say plus 1. So x will be 11. And if you take x minus 10 as plus 1, we get 10 plus 101, which will be 111. So first case is x11, y111. Similarly, second will be 9 minus 91. Third will be 111 and y will be 11. Fourth will be x minus 91, y will be 9. So total there will be 4 solutions. This is an important topic, guys, will be helpful in other problems also, this thing. Okay, next guys. Next, we have series problems in which there's some series of inverse function will be asked. Remember few points here. Every series problem has to be solved in tan inverse only. Okay, sometimes they give a series of tan inverse, we solve in tan inverse. If they give in sine inverse, cos inverse of any other thing, you will convert into tan inverse and then do in tan inverse. Because every series problem will be solved in tan inverse only. Next, convert thing inside tan inverse into form x minus y by 1 plus xy. So that tan inverse x minus y by 1 plus x plus x 1 plus xy we can write as tan inverse x minus tan inverse y. I hope it makes sense. Now, when you write the series now on this thing, you will see the consecutive terms get cancelled out, and we get starting and ending terms only. One second. And we get starting and ending terms only. Okay, whatever points I've explained here, let us see with the help of example. Let us say question is tan inverse 1 by 3 plus tan inverse 2 by 9 plus tan inverse 4 by 33 up to infinity. Some tan series is there. What you do is write the first term 1 by 3 as 3 we can write as 1 plus 2 into 1, and the 1 in the numerator we can write as 2 minus 1. You see now x minus y by 1 plus xy. So we can write this thing as tan inverse 2. One second. One second, guys. So we can write this thing as tan inverse 2 minus tan inverse 1. This 2 by 9 will become, denominator will become 1 plus 4 into 2. Numerator will be 4 minus 2. This will become tan inverse 4 minus tan inverse 2. 4 by 33 will become, denominator will be 1 plus 8 into 4. Numerator will be 8 minus 4. We get tan inverse 8 minus tan inverse 4 up to infinity. So now you will see that this tan inverse 2 will get cancelled out with tan inverse 2 here. Tan inverse 4 get cancelled out with tan inverse 4 here. Similarly, tan inverse 8 will be cancelled out with the next term. And when you write all of them, all the middle term will get cancelled out. Remaining will be first and last. You see, first is the minus tan inverse 1. And last will be tan inverse of infinity. So this is tan inverse of infinity because it goes up to infinite terms. And tan inverse infinity we can say will be pi by 2. Tan inverse 1 is pi by 4, so you get pi by 4. I hope it is clear to all of you guys. This is an important log concept. They do ask these kind of questions. Let us try the next problem yourself. Okay. We have tan inverse 1 by 3 plus tan inverse 1 by 7 plus tan inverse 1 by 13 plus tan inverse 1 by 21 up to infinity. You can give it a try, guys. Let's start discussion. This 1 by 3 again you can write as 2 minus 1 by 1 plus 1 into 2. 1 by 7 you can write as 3 minus 2 by 1 plus 2 into 3. 1 by 13 you can write as 4 minus 3 by 1 plus 3 into 4 and infinite up to so on. So first will be tan inverse 2 minus tan inverse 1, then tan inverse 3 minus tan inverse 2 and so on. Again, all the middle term get cancelled out. Remaining will be first and last. So tan inverse infinity minus tan inverse 1 equal to pi by 2 minus pi by 4. Again, you get answer as pi by 4. Okay, I hope it is clear, guys. Next one. Now they'll give some problems in terms of this summation and all. So summation are 1 to infinity tan inverse of 1 by 2 power r plus 2 power 1 minus r. Give it a try, guys, then we'll start discussion. Let us start now. So this 1 by 2 power r plus this we can write as 1 by 2 power r minus 1, taking reciprocal of this thing. Now if you take LCM, you get 2 power r minus 1 by 1 plus 2 power r into 2 power r minus 1. Now this is 1 plus xy form, and in the numerator you will see if you write 2 power r minus 2 power r minus 1, it's equal to this thing only. 2 power r minus 2 power r minus 1 will be 2 power r minus 1 only. So now you get x minus y by 1 plus xy. Inside tan inverse will become tan inverse x minus tan inverse y. Now you put summation r1 to infinity. So when you put r1, you get tan inverse 2 minus tan inverse 1. Next tan inverse 4 minus tan inverse 2 up to infinity. So all the middle term get cancelled out. Remaining will be first and last. So tan inverse infinity minus tan inverse 1. Again, you get answer to be pi by 4. Okay, it's not like every time it will be pi by 4. It's just accidentally all first three volume got answered as pi by 4. Okay, let us do this next problem. This is a previous year JEE advanced problem. They're asking chord of summation n1 to 23, chord inverse of 1 plus summation k1 to n of 2k. Okay, this is a good problem. Give it a try. Let's start discussion. First of all, summation k1 to n of 2k. It's like will be 2 plus 4 plus 6 up to 2n. You can easily use any formula you have learnt in sequence and series. It will come out to be n into n plus 1. So the thing inside this outer chord, I'm just writing here, it becomes summation n1 to 23 chord inverse of 1 plus n into n plus 1. Now chord inverse of this thing we can write as tan inverse of 1 by this thing. So get tan inverse of 1 by 1 plus n into n plus 1. Now this 1 we can also write as n plus 1 minus n, because now it will become x minus y by 1 plus xy form. So you get tan inverse n plus 1 minus tan inverse of n. Now again you put summation n1 to 23, get tan inverse 2 minus tan inverse 1 plus tan inverse 3 minus tan inverse 2. Last term will be tan inverse 24 minus tan inverse 23. So all the middle term get cancelled out. Remaining will be first and last. Get tan inverse 24 minus tan inverse 1. Now again is the formula of tan inverse x minus tan inverse y. You get tan inverse of 24 minus 1 by 1 plus 1 into 24. You get tan inverse 23 by 25. In the question, there is outside a chord also, so you get chord of tan inverse of 23 by 25. Tan inverse you can convert into chord inverse 25 by 23. We discussed already. And chord of chord inverse 25 by 23 will just be 25 by 23. So the final answer here is just 25 by 23. I hope it is clear, guys. Next, one last problem on the series thing. Give it a try. So we have summation n1 to infinity tan inverse of 2 by n square plus n plus 4. You can pause the video, give it a try. Let us start discussion now. The answer here finally is tan inverse of 2. See, this 2 by n square plus n plus 4. How do we convert into x minus y form? We divide by 4 both sides. Why 4? Because this 4 will then become 1. So you get 1 plus n square plus n by 4 and numerator will be 1 by 2. Now this denominator, if you factorize, you get n into n plus 1. And the 4 also you did write as 2 into 2. So you get n by 2, n plus 1 by 2. You see difference between them is 1 by 2. So the numerator 1 by 2 we can write as n plus 1 by 2 minus n by 2. So now you get tan inverse of x minus y by 1 plus xy, which will become tan inverse of x minus tan inverse of y. Now you put r or 1 n here. Now you put n 1 to infinity. So when you put 1 here, you get tan inverse 2 by 2 minus tan inverse 1 by 2. When you put 2 here, you get tan inverse 3 by 2 minus tan inverse 2 by 2 up to infinity. You will see all the middle terms will get cancelled out. Remaining will be first and last. So last will be tan inverse infinity minus tan inverse half. So tan inverse infinity, is pi by 2. So pi by 2 minus tan inverse of half will become cot inverse 1 by 2, which will be tan inverse 2. So final answer will just be tan inverse 2. I hope it is clear, guys. Next. Next, like I told you, these extra formulae, but you just need to see them. No need to mug up anything. We rarely use this. Just for you completion of the topic, I've written here. Otherwise, I never use them. Cos inverse x plus cos inverse y will be cos inverse of xy minus root 1 minus x square into root 1 minus y square when x and y greater than equal to 0. Cos inverse x minus cos inverse y is cos inverse of xy plus root 1 minus x square root 1 minus y square when xy both are positive and x less than equal to y, and there will be negative outside if xy both are positive and x more than y. Sin inverse x plus sin inverse y will be sin inverse x root 1 minus y square plus y root 1 minus x square when x and y are positive and x square plus y square is less than equal to 1. And it will be pi minus sin inverse x root 1 minus y square plus y root 1 minus x square when x and y greater than equal to 0 and x square plus y square is more than 1. Like I told you, no need to mug it up. Later on, we'll discuss some techniques with which you can solve problems without mugging up the formula. Okay, just for the completion of the topic I have written here, no need to use them. Leave it. And formula of tan inverse when more than two terms are there. But here conditions and all will not mug up. I just give you the formula. Again, rarely will use. Tan inverse x plus tan inverse y plus tan inverse z will be tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz minus zx. Again, conditions will be there, but we don't need to mug it up here. If conditions matter in the problem, you can just do it pair by pair. First solve these two, then solve with this thing. If you see conditions don't matter there, you just use it directly then. And if there are more than three angles, let us say tan inverse x1 plus tan inverse x2 up to tan inverse xn, then will be tan inverse of s1 minus s3 plus s5 minus so on by 1 minus s2 plus s4 minus s6 and so on. What is s1? You can say sum of terms taken one term at a time. x1 plus x2 plus x3 up to xn. What is s2? Sum of terms taken two at a time. x1, x2, x2, x3, x3, x4, like all the possible combinations that we can get of two terms. We have to add them all. Similarly, in S3, three terms at a time, S4, four terms at a time, and so on. Again, rarely we use, rarely. Okay, just for the sake of completion of topic, I have written here. Next, guys. Next, we discuss solving equation. See, in this solving equations part, we'll have inverse trigonometric equations and we'll have to solve them. So whatever concept we have discussed till now, we'll have to apply them to solve these equations. So this first problem I'll discuss, then next problem you can try. We have sine inverse 5 over x plus sine inverse 12 over x is equal to pi by 2. We have to find the value of x. Now, first of all, you can see that x has to be positive only. Why? Because if x will be negative, this thing will be negative, this thing will be negative, and sum of two negatives cannot be plus pi by 2. So x has to be positive, only then both the terms will be positive. So sine inverse 5 over x we can write as pi by 2 minus sine inverse 12 by x, which will become cos inverse 12 by x. Now using the triangle thing, we can convert cos inverse into sine inverse. So if I take this thing as theta, cos theta will be 12 over x. So base is 12 and hypotenuse will be x. So this will come out to be root of x square minus 12 square. So sine inverse will be perpendicular upon hypotenuse. So you get sine inverse root x square minus 144 by x is equal to sine inverse 5 over x. So from here you can say 5 over x equal to square root of x square minus 144 by x. So x square will come out to be 169. So x has to be 13 only because x is positive. We'll have to ignore minus 13. So final answer is just x equal to 13. So this is the first problem. Try the second one yourself. I'll give you time. Sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2. Solve for x. Give it a try. Pause the video. Let's start the discussion. The answer here is just x equal to 0. See, for this, first of all, again, we see the domain. What is the common domain of the thing? You see sine inverse 1 minus x. Here 1 minus x should lie between minus 1 to 1. Here x lie between minus 1 to 1. The common domain will be just 0 to 1. Now for 0 to 1, if I write sine inverse 1 minus x on the left side, pi by 2 plus 2 sine inverse x on the right side, for x 0 to 1, we can say the minimum value of the right side will be pi by 2, because sine inverse x will always be positive, like greater than equal to 0. And the maximum value of sine inverse is also pi by 2. So this is maximum pi by 2, this is minimum pi by 2. So only way we can get a solution is this is maximum, this is minimum. So sine inverse 1 minus x should be pi by 2 and sine inverse x should be 0. Both of them will occur at x equal to 0. So we can say answer will be 0. Okay, it is important because we should take common value. You want both of them to be true at the same time. So let us say if x was 0 here and x was 1 here, then answer would have been no solution. Because we are supposed to take common values. Here x0, here x0, so common value is x equal to 0. I hope it makes sense, guys. Next one. We have tan inverse of 2x plus tan inverse of 3x equals to pi by 2. Give it a try. Let's start discussion now. The answer for this problem is only 1 by 6. See here, tan inverse 2x plus tan inverse 3x. Again, you can see that x has to be positive, because otherwise this thing will be, if x is negative, this will be negative, this will be negative, and sum of two negatives can't be positive. So now we use the formula tan inverse of 2x plus 3x over 1 minus 6x square. You see, denominator should not be negative if you want to use the regular formula. So 6x square, so I make a case here, 6x square is less than 1. So we can just use the normal formula then. So it will be equal to pi by 4. That is only possible if this thing is equal to 1. We got a quadratic 6x square plus 5x minus 1 equal to 0. Roots will be minus 1 and 1 by 6. And like I told you, negative value is not possible. Plus 6x square should be less than 1 also. So 1 by 6 will be the only solution which will satisfy this. Next case, when the denominator is negative. So 6x square is more than 1. And like we discussed, both the terms has to be positive. So this thing will come out to be negative. So to make it positive, we have to add pi. And then you get tan inverse of 5x over 1 minus 6x square equal to minus 3 pi by 4. And you know, tan inverse range is minus pi by 2 to plus pi by 2. So equal to minus 3 pi by 4 is not possible. So second case does not give us any solution. So only solution will be x equal to 1 by 6. I hope it is clear, guys. Okay, guys. Next we have fourth problem. You can give it a try. Step of cot inverse x plus step of cos inverse x is equal to 0. You can pause and give it a try. Let's start discussion now. If you remember, cot inverse x can never be negative, cos inverse x can never be negative. So this thing will be 0 only if both of them are 0. So step of cot inverse x equal to 0, step of cos inverse x equal to 0. So that means cot inverse x should lie between close 0 to open 1 and cos inverse x should lie between close 0 to open 1. So from here you get x belongs to, you remember cot inverse is a decreasing function. So minimum value will be cot 1 and maximum will be cot 0. Cot 0 is plus infinity. And here we get cos inverse x lie from close 0 to open 1, and cos inverse also decreasing function. So minimum value will be cos 1 and maximum will be cos 0, which is 1. So x belongs to cot 1 to infinity here, x belongs to cos 1 to 1. Now we have to find the common values. So what you will see, first of all, just draw a number line. You will see that 1 will be more than cot 1, which will be more than cos 1. So how do we say this thing? You see, cot 1 will be cos 1 into sin 1. Sorry, cos 1 by sin 1. And 1 sin 1 will be less than 1. So 1 by sin 1 will be more than 1. So this will obviously be more than cos 1. And to compare 1 and cot 1, we can say cot inverse pi by 4 will be, you say pi by 4 is less than 1. And if I take cot both sides, you see cot is a decreasing function. So cot pi by 4 then will be more than cot 1, and cot pi by 4 is 1. So 1 is more than cot 1, which is more than cos 1. So we'll get cos 1 is the smallest, then cot 1, then 1. And first thing says cot 1 to infinity. So it will be this to this. Second is cos 1 to 1. The common values will be cot 1 to 1. The final answer here is open cot 1 to close 1. I hope it is clear, guys. Next problem. If tan inverse x square plus tan inverse y square equal to step of xy into pi by 4, where x and y are positive, then the ratio of maximum to minimum value of step of x square plus y square. Okay, give it a try, guys. Then we'll start discussion. Let's start now. See, first of all, this step xy here. So we obviously have to make cases for this xy. So first case I make here, xy lie between 0 and 1. You see x and y both are positive. So xy will always be positive. So first case is when it lie between 0 and 1. So step in this case will be 0. So you get tan inverse x square plus tan inverse y square equal to 0. You see x and y both are greater than 0. So this value will also be greater than 0. This is also greater than 0. So sum of two positive numbers cannot be 0. So it will be not possible. Next, when xy lie between 1 to 2. In that case, you see step will come out to be 1. So you get pi by 4 on the right side. And on the left side, we have tan inverse x square plus tan inverse y square. Now, when you use the formula, you get tan inverse of x square plus y square by 1 minus xy square. You see, xy will be more than 1. So the denominator is negative. But the final value should be positive, so we add pi. Because these both the terms are positive. So we get tan inverse x square plus y square by 1 minus x square y square equal to minus 3 pi by 4. Again, it won't be possible. Because the range of tan inverse is minus pi by 2 to plus pi by 2. Third case, when xy lie between 2 to 3, so we get tan inverse x square plus tan inverse y square equal to pi by 2. Again, use the formula, you get tan inverse x square plus y square by 1 minus xy whole square plus pi equal to pi by 2. You take pi to other side, you get minus pi by 2. Again, the range of tan inverse is open minus pi by 2 to plus pi by 2 open. So minus pi by 2 still not in the range. So again, this case will be not possible. Next case, when xy belongs to close 3 to open 4. In that case, you will get tan inverse x square plus tan inverse y square equal to 3 pi by 4. In this case, when you use the formula, you get plus pi equal to 3 pi by 4. Now you get this thing to be equal to minus pi by 4, which is in the range. So this will be minus pi by 4 when this thing will be minus 1. So you get x square plus y square by 1 minus x square y 1 minus xy square equal to minus 1, which will give you x square plus y square equal to xy square minus 1. Now the range of xy is 3 to 4. So when xy is minimum, this thing will also be minimum. When xy is maximum, this thing will also be maximum. So put 3 here, you get 8. Put 4 here, you get 15. But you see, 3 is closed, 4 is open. So we take close 8 to close 15. So from here we get a solution that x square plus y square belongs to close 8 to open 15. Okay, next. In the next case, you get xy belongs to close 4 to open 5. But in this case, the right side, the step xy will become 4. So this will become pi, which will go out of the range now. Because the range of this thing is open pi by 2, open pi by 2 are the maximum values. So if you add them, we get maximum will be open pi, not equal to pi. So this will not be possible, and no other value after this will be possible because everything will be more than the range here then. So there is no solution after that possible. So at the end, only possibility we get is when x square plus y square belongs to close A to open 15. So maximum value of step x square plus y square will be 14. Minimum value of step x square plus y square will be 8. So ratio will be 14 over 8. So answer will be 7 over 4. This is a very good problem, guys. Make sure you understand this thing. Next. Now we'll do some practice problems based upon the concepts we have covered in this chapter. Some typical problems we have here. First one is this. We have to simplify this thing. Sine inverse x root 1 minus x minus square root x root 1 minus x square. Okay, we have to just simplify this thing. You can give it a try, then we'll start discussion. Let's start discussion now. First of all, if you see the common domain thing, you see this thing should be greater than 0, this thing should be greater than 0, this thing should be greater than 0. When you take everything, common values will be x0 to 1 only. Okay, so domain is x0 to 1. Now we have like similar kind of things here. Here we have x, here we have root x. What I'll do is I'll take x as sine A. So A will be sine inverse x, and you see x is 0 to 1, so A will lie between 0 to pi by 2. Then cos A will become root of 1 minus x square. Okay, cos A would have been like plus minus this thing. But as you can see, A is in the first quadrant, so cos A has to be positive. So cos A will be root of 1 minus x square. Now, interesting thing I'll do is I'll take root x as sine B. Now you might see that x is sine A, then root x as sine B. So then we can say that sine B will be root of sine A. Yeah, we can say that. That's correct. But I'm just taking this thing to simplify this thing. So we can do it. Sine A, like sine A and sine B will become dependent on each other. That is fine. So root x equal to sine B. So B will be sine inverse root x, and again B will also lie between 0 to pi by 2. And cos B in this case will become root of 1 minus x. Okay. Now, so the given problem will become sine inverse of, I write this x as sine A and this as cos B. This as cos A and this as cos B. So it will be something is not correct here. Yeah, this have been cos A and sine B. So x is sine A and root 1 minus x is cos B from here. Now root x is sine B, we assumed here, and root of 1 minus x square will be cos A, we got from here. Why we are doing this thing? It looked like a formula, sine A minus B. Sine A cos B minus cos A sine B will be sine A minus B. Now which sine inverse sine A minus B, sorry, sine inverse of sine x, if you remember, I told you we can cancel out these only if it is in the range. So A minus B, how do we check that? See here. If x belongs to 0 to 1, you can say x will be less than root x. Because if number is between 0 and 1, higher the power, lower is the value. So x power 1 here, x power 1 by 2, so obviously 1 by 2 will have higher value. Then sine inverse x will also be less than sine inverse root x because sine is increasing function. So A will be less than B. So a minus b, when you do, it will be negative, and the minimum value will be minus pi by 2. It will be minimum when a is maximum, which is pi by 2, and b is minimum, which is 0. But sorry, we discussed already a has to be less than b. So value will be negative, and how negative it can go? The least value will be when a is 0 and b is pi by 2. There will be minus pi by 2. So overall, a minus b will belong between minus pi by 2 and 0. And that means this lies in the range of sine inverse x. So we can cancel out these, we get only a minus b. And a, as we discussed, was sine inverse x. B, as we discussed, was sine inverse root x. So finally we get sine inverse x minus sine inverse root x. Okay, this is a good problem, guys. Make sure you understand this thing. Next. A good series problem, summation n1 to infinity tan inverse of 4n by n power 4 minus 2n square plus 2. You can pause the video, give it a try. Let us start discussion now. So first of all, this thing we try to simplify in the form of x minus y by 1 plus xy. What you can see is this we can write as 1 plus. You see, if I split here, you get n square minus 1 whole square plus 1. Complete the square. And this you can use a plus b, a minus b, you get n plus 1, n minus 1, so whole square. And in the numerator will be nothing but difference of these two. If you subtract these two, you get 4n. So we can write this as n plus 1 square minus n minus 1 square. So overall, this will become tan inverse x minus y by 1 plus xy. So it will be tan inverse x minus tan inverse y. Now, one interesting thing you will see here is the difference between, like, this is n plus 1, this is n minus 1. The difference here is of two terms, like 2. N plus 1 minus n minus 1. If we subtract, you get 2. How will that play out? You see here. If I put n as 1, you get tan inverse 2 square minus tan inverse 0. Put n as 2, we get tan inverse 3 square minus tan inverse 1 square. Put n as 3, we get tan inverse 4 square minus tan inverse 2 square. You will see that tan inverse 2 square will get cancelled out with the third term here. The third bracket. So nothing cancel tan inverse 0, nothing cancel tan inverse 1 square. So terms start to cancel out from the third bracket. That means the first two terms, like from the first two brackets, one term is pending. So we can say first two terms are pending, then last two terms will be pending. So when the difference here you will see is of 2. Okay, I'm not talking about square right now. Just this thing. If the difference is 2, you will see that first two and last two terms will be pending. So first two terms are of the negative side. This will be tan inverse 0, tan inverse 1. And last two terms will be the positive side. There will be tan inverse infinity only. In the last two terms, you'll have tan inverse infinity and tan inverse infinity. So both of them we can write as pi by 2. First two terms are these 0 and this will be pi by 4. So you get pi minus pi by 4, you get 3 pi by 4. So this is interesting, guys. Here, first two and last two terms are pending. Last two terms both will be almost infinity, so we can just use pi by 2. Okay, well, last problem for now. How do you plot the graph of sine inverse of mod sine x? It might sound easy, but people do get confused here. So I'll just give you a very simple technique. For sine inverse mod sine x, we remember the graph of sine inverse sine x. We'll try to use that here. First of all, you will see the period of this thing will be pi now, because mod sine x period is pi. So if period is pi, I'll just see the graph from 0 to pi, and same thing we can repeat everywhere because period is pi. In 0 to pi, we can say sine x is greater than equal to 0, so mod sine x will open with sine x only. That means in 0 to pi, we can say sine inverse mod sine x behaves same as sine inverse sine x. And if you just see the zigzag graph between 0 and pi, the graph looks something like this.
So if this is the graph between 0 and pi, we can say same thing will repeat everywhere because the period is pi. That is all. This line you can check from there is y equal to x. This line you can check from the graph will be y equal to pi minus x. Okay, then same graph whatever you get a triangle here, same triangles will be everywhere. Okay, I hope it is clear, guys. This is all about ITF. So we have covered the basic points and the basic problems. More you can practice from whatever material guys you have. Okay, guys, then bye bye.